let's look at fluorine. I'm going to have it two different ways here. We have fluorine's number 9 on the atomic number, 19 here, and I'm going to show it as F19, 9. Okay, so let's just say I want to calculate protons, neutrons, and electrons for a fluorine atom. Now, since the mass number is the same both here and in the symbol, I know that I'm not dealing with an isotope necessarily of fluorine. It's a standard fluorine atom. So to solve for this, so I know that the protons are equal to, and that should be a P with a plus, there we go. The protons are equal to the atomic number. The electrons are equal to the protons, at least when there's no charge. And the neutrons are equal to the mass number minus the protons, because the mass of the atom is coming from the nucleus. So we have mass number equals protons plus neutrons. We can write that here too. Mass equals protons plus neutrons. And since I know all the mass comes from the nucleus, then I also know that if I subtract away the protons, I get neutrons. Okay, so let's try that for fluorine. So that would mean that the protons for fluorine would equal 9. And I can get that from right here or right here. Okay, there's my atomic numbers. The electrons, we said, were equal to the protons when there's no charge. And if there was a charge, you would see something here. But since there's nothing there, we know there's no charge. So that's 9 electrons. And as for the neutrons, we said it's equal to the mass number, 19, minus the protons, 9. So for fluorine, I have 10 neutrons, 9 electrons, and 9 protons. Okay, well, this is for a standard atom of fluorine. But what if it's not a standard atom? What if we have a charge on it? So if I have a charge, again, let's start with this time I have fluorine, 9, 19, minus 1. Okay, so everything else that we were talking about is still the same. Actually, hold on, maybe you caught that. I made a little bit of a mistake here. The 9 should go on the bottom, and the 19 should go on top. Okay, so now let's talk about how we handle this charge. Well, some things are not going to change. I know that the number of protons is equal to the atomic number, so I have 9 protons for fluorine. I know the neutrons are equal to the mass number, which was 19, minus 9, so I have 10 neutrons. When I have a charge, it's the electrons that I have to be careful about. The number of protons, as you heard Hank discuss in the video, does not change because the protons give the element its identity. So if the protons don't change, and they're the positive charge things, and I have a charge here that's not 0, that means the number of electrons must have changed. So let's take a look at how we figure this out. I said I have 9 protons. Each proton gives a plus 1 charge, and I have 9 electrons, or 9 protons, sorry. 9 protons. So that means I have a plus 9 charge coming from my protons. Now the neutrons, they have no charge, so it's like 10 times 0, so I don't have to worry about them here. But I do have to worry about the electrons. So I have a plus 9 charge. I know the electrons are negative. I have no idea right now how many of them I have, but I know that when I combine the protons and the electrons, I have to be left with a minus 1 charge. So if you were in math class, you would have this problem actually. 9 minus blank equals -1. So hopefully you figured out that 9 minus 10 equals -1, which means that I have 10 electrons. Whenever you see a negative charge, as we do here, you know that you have more electrons than you do protons, and I think that's probably worth writing down. So we can do that. So let's take a look at how, or let's just write that down. So we know that if we have a negative charge, and maybe I can erase a couple things here. Doesn't really want to erase. So if I have a negative charge, that means that the electrons are greater than the protons. And if I have a positive charge, then that means the electrons are less than the protons. And I think that's probably a good thing to include inside your notes. Okay, so the last thing is, well, what if I have an isotope? Okay, so we talked about an atom, we talked about ions with a charge. What about an isotope? So when we talk about isotopes, we are talking about things that have a different number of neutrons, a different mass number. And if you look on the periodic table here, you will notice that these mass numbers are not whole numbers. At least not all of them are whole numbers. For example, boron is 10.81. Fluorine is 19 even. Chlorine is 35.45. Sulfur is 32.06. You have decimal places here, but that's kind of odd because we said that the mass number is equal to protons and neutrons. So if you have a decimal, then how could that be? How could you have, in magnesium's case, 0.31 neutrons? And the answer is you can't. And what we find out is if we look at something like magnesium, and if we have something like magnesium, which has some atomic number 12, Mg, 24 point, I think it was 30. That's like that because this number here is an average. Because most of the time we are dealing with magnesium 24, but sometimes we are dealing with magnesium 25, which means that it has an additional neutron there. So because sometimes magnesium exists as magnesium 24 and sometimes it exists as magnesium 25, this number here represents both of them. Now, since this is closer to 24, it means most of the time it's magnesium 24. But there are magnesium 25 isotopes that do exist in nature. So to calculate this, again, some of it doesn't change. Protons are always equal to the atomic number. There are 12 of them here. Electrons, there's no charge here, so the electrons have to be equal to the protons. The neutrons are still equal to the mass number minus the protons. But remember, if the mass number is given to you as part of a separate name, that's what you have to use. So instead of 24 minus 12, it's 25 minus 12, which means magnesium 25 has 13 neutrons and not 12. All right, so let's try one more order problem here. Let's say that we have magnesium 26, 12 plus 2. So you get this whole symbol here. All right, well, let's go through. And whenever we're calculating protons, neutrons, and electrons, we have elements. So since let's make this a little bit nicer. Since I know the atomic number is 12, I have 12 protons. Okay, so now that's done. So now I have electrons and I have neutrons. And neutrons, I know, are the mass number minus the number of protons. Well, the mass number is always given on the top of this symbol here. Now, I know if you look on the periodic table, magnesium is number 24, but here it says we have magnesium 26. I take away the protons. I have 14 neutrons, 12 protons. All right, now here we go again with the charge. I know I have a plus 12 from the protons. I have to combine some number of electrons so that what I have left over is a plus 2. Okay, I know the electrons are going to be negative. So in other words, 12 minus blank equals 2. Well, 12 minus 10 equals plus 2. So I know I have 10 electrons. And now that also follows our rule that if I have a positive charge, the number of electrons should be less than the number of protons. Again, the number of electrons can change, and we'll learn why in the future, but the number of protons does not. Now use that to go ahead and work on your worksheets, and if you have any other questions, just ask.